Hello and welcome to this screencast on design patterns. And I had a previous screencast, which you should definitely watch prior to this one, that talks about design patterns in general and gives a kind of a 30,000 foot level of design patterns. That's a good one to watch before this one because I'm not going to go over that material. I'm going to reference it slightly, but I'm not going to go into detail on it. In this case, what I want to do is go from the 30,000 foot level to ground level and show you actual instances of code that's written using design patterns. So you get a much more concrete idea. In this class, we're using JavaScript, we're using Meteor, and I'm having you look at this sample system called Bowfolios. So hopefully this will be easy for you to kind of understand. The Bowfolios system, bowfolios.github.io. Here's where the code is if you want to go look at it yourself. We're going to look at about 6 different design patterns in this screencast, and there's many more. Like the event handler in JavaScript is an example of the observer pattern and so forth. But I'm just going to highlight some that are pretty easy to pick out and understand. And it turns out that in the Bowfolio system, since it's built on Meteor and since Meteor is a JavaScript system, I'm going to show you examples of design patterns specific to any JavaScript system, some design patterns that are specific to any Meteor system, and then a couple that are specific just to Bowfolios. So let's get started. The first one, the prototype design pattern. This is one of the things that JavaScript is super famous for because it does not use classical classical class instantiation where you have classes versus instances. In JavaScript, you don't have that idea. You only have instances, and you use the prototype design pattern to build new instances from other instances. Now, JavaScript does have a class keyword as of ES5 or ES6 or one of those recent versions, but that's just syntactic sugar over this underlying idea that you always start with one object and then, by mitosis in a way, create a clone of it to create your new objects. That's as opposed to the kind of cookie cutter stamping mechanism that languages like Java or C++ use to create their instances. For more details on this, I've got a whole screencast about the differences between object orientation in Java and JavaScript. You can go watch that if you'd like to learn more. But anyway, the point is, anytime you use JavaScript or anytime you use the quote-unquote class idea in JavaScript, you're using an example of the prototype design pattern. And just as a simple example in Bowfolios, you can see that we have this set of classes. It's in the API directory that are basically used to encapsulate underlying Mongo collections. And so this is where we're using this prototype design pattern. Now, we're not exploiting really the great functionality of the prototype design pattern in this case. We could have, for the purposes of Bowfolio, it could have been a classical, class instance thing, and it would have worked just as well. But in fact, we're using prototypes. Second design pattern, is the observer design pattern. And remember, at the high level, the observer design pattern is this notion that we have a subject, and whenever the state of the subject changes, you want a bunch of other objects to be able to react to that state change. Okay, so that's the essential idea. This is the classical, kind of object-oriented structure for the observer design pattern, in an object-oriented system. There's a very closely related design pattern called publish-subscribe, and it basically implements that same level of decoupling between things whose state changes and the folks that want to know when that state changes, but it does it in a kind of a message-oriented paradigm. So you're not having a list of observers that you call the notify method on. Instead, you've got this higher level kind of architectural mechanism where you have a set of data sources, you'll call them the publishers, and they specify the way that they want to make data available, and that's provided to, in this diagram, an event bus, which is some mechanism which, when the publisher when any one of these publishers have some kind of new state or something, they tell the event bus about it, and the event bus is responsible for telling anybody, any other instances or objects out there who care about that particular publication, that the publication has changed. So it's just like the observer pattern, at the high level, but the details of the implementation are different. It turns out that in Meteor, this publish-subscribe model, architectural model, is really fundamental to the way Meteor works in terms of data flow and communication. Okay, so they just directly implement the idea of publishers and subscribers, and then they build in the event bus stuff, so you don't have to worry about that. And if you want to learn more about this in detail, I'm showing you the section from the Meteor guide where they go into this. So I'm just going to show you in Bowfolios how we actually go about doing that. Inside the base collection class, which is the superclass of all our collection classes, there is a method called publish, and what that's going to do when that method is invoked is create a Meteor publication that basically says when you subscribe to that publication, what you're going to get is a cursor to the contents of the entire collection. So this is like the most simplest possible way you can think of publication and subscription, where you're just giving the whole shooting match off to anybody who wants information about your collection. And once you get into more sophisticated applications, you're going to want to restrict the kinds of publications that are available based upon who's requesting it. So you have a to-do list, you only want to see the to-dos that you actually made, and so on and so forth. And there's a gazillion different examples of how you do that out there. So anyway, but this is an example of the publish call. You can see that I have this if meteor.isServer as a way of noting or making sure that only when this code is run on the server side will this publish method be called. Okay, and then you can see here over in the startup package, when the system is initially loaded, we have to actually invoke that method. And now that we've invoked that method, we've actually created that Meteor publication. So now it exists in the system at runtime, and we can subscribe to it, which is what we do here on this page. So now we've moved over into the UI section of our code base, and we're in profilepage.js, and profiles need to have information about the set of profiles in the system as well as the set of interests in the system. So we call the Meteor subscribe method, passing it the name of the publication associated with profiles and the name of the publication associated with the interest. Well, the name of the publication is associated with the profiles collection and the name of the publication associated with the interest collection. And we use this.subscribe because basically the way this code in Meteor works is that whenever we create this specific page, a profile page, part of the creation process is to say, hey, I need to now have access to the data about profiles and the data about interest so that I can actually display profile and interest data. Okay? That's how that works. All right, so that's the observer pattern, the publish subscribe pattern. I'm sorry, that's one example of the observer pattern, which is publish subscribe. Another example of the observer pattern is the whole notion of reactive data in Meteor. And this is kind of a fundamental construct. You should be getting familiar with this by now, which is the idea that, for example, when a MongoDB collection is updated, if there's code on the client side that references a cursor in that collection, okay, that code will be rerun. So, that cursor is an example of a reactive, variable, just implicitly by virtue of the way you use Mongo. On the client side, if you define a cursor to a collection with mini Mongo, that's a reactive variable, which means that whenever that underlying collection is updated, Meteor is going to want to rerun anything that involved that collection, such as cursors, to update the view with the new state. Okay, so that's kind of an implicit thing. Every time you use a MongoDB collection, you get that kind of for free. Sometimes, quite frequently, you want to have that notion of reactivity, of something of the view automatically being updated, but you don't want to have to create a whole darn collection to do that. And so there are these constructs in Meteor called reactive variables and reactive dictionaries, which give you that reactive thing without having to go create a collection just to get the reactive data. Okay, so those are two very nice things. Let's see some examples. Here's an example of the first one where the directory page has a helper named profiles, and what it does is it returns a cursor, which is the result of calling the find method of the profiles collection with this empty selector, which means it's going to find every object within that collection, and it's going to return the cursor where it's sorted. The instances in it are sorted by the last name. And then when we refer to that in directory page.html, we're going to list out all of the profiles, and furthermore, whenever this collection is updated, this code will be rerun, which means this profile method will be re-invoked, which means the directory page will be updated. Super cool, when you think about it. Okay, here's an example of the use of a reactive dictionary in Bowfolios, and here what you can see is we want to be able to reactively update the display depending upon whether our form succeeded or failed, and to do that we have this variable called message flags, which is defined to be an instance of a reactive dictionary, and we can set fields within that dictionary, or it's key value pairs. We can set keys to be, in this case, initially false, and then down in our code later we can set them to true if we want them, if we want something to happen, and then all the code associated, all of these methods where the message flags reactive dictionary is referenced are going to be rerun, and the display will be updated appropriately. Okay, so that was the observer pattern, two examples of it, one involving publish subscribe and one involving these reactive variables. Let's move on to ModelViewController. This is the kind of the 800-pound gorilla of web application design patterns. Maybe it's the 8,000-pound gorilla of web application design patterns, because I don't think there's any modern framework which doesn't have some variant of MVC in it. It's just, it's kind of the gold standard. There are, like ModelViewPresenter and, some minor variants, but they all kind of involve this design pattern. Meteor is no exception. In Meteor, what happens, you have the MVC pattern, and in the case of Bowfolios, the model is going to be a MongoDB database. The view is going to be a templating system called Blaze, and the controller is going to be this routing mechanism called Flow Router. Now, what's kind of cool about Meteor is that it doesn't hardwire any of these decisions in. For different applications, you can choose different instances for each of these. So I'll show you one example of a difference where the model would be this GraphQL mechanism or technology, which actually enables you to kind of have your backend database be either a SQL database or a NoSQL database. The view, instead of being Blaze, could be React, which is very popular front-end framework, and then for the controller you could choose something like React Router. Okay, but again, we've got some MVC stuff going on. So let's look and see how in Bowfolios we do that. The model is going to be MongoDB collection, and in Bowfolios the way that we implement that is by having these collection classes. I'm showing you the base collection, the superclass here, because that's the one where you can actually see the creation of the Mongo collection. But this is in some sense an abstract superclass, so we never actually instantiate this directly. Although of course in JavaScript there's nothing preventing us from doing that, but basically Bowfolios doesn't work, or you wouldn't get anything interesting if you tried to make an instance of it. Instead, you make instances of the interest collection and the profile collection, which are the subclasses of this, and that implicitly calls this constructor, and so you get a collection. The view in Bowfolios is the use of the Blaze templating language. Here's an example from directory-page.html. You got this template thing, and this expresses the view, which is going to loop through and create a bunch of directory profile objects, or yeah, we'll call them objects. Finally, for the controller, we're using flow router, and that's defined in import startup client router.js, and you can see it's just a bunch of calls to flow router to do the various things that routing packages do. Okay, so there's the example of how MVC is implemented in Bowfolios. Very, very straightforward. Parenthetically, I guess I will note that there's another design pattern called FrontController, and FrontController is a centralized request handling mechanism. In the case of web application frameworks, the idea is that you have this FrontController which gets the request from the client and may do authentication, authorization, logging, etc., and then pass the request on to corresponding handlers. In Meteor, flow router is one package that implements the design pattern. React router, any kind of router basically is implementing the FrontController design pattern. If we just go back to this slide, you can see that essentially, we have this flow router, it gets directory, and then the action is to send it out to, this directory layout with a specific page inside. And we've got, if I were to scroll down, you could see that there would be a bunch of other calls to this. Here's one for the landing page, where we route, instead of to directory layout with directory page, we route to the landing layout with the landing page route name. Okay. Yeah, and then, for example, the router can do other stuff in addition to simply going from the request to the page. In this case, we've got these triggers. Flow router defines these things called triggers, which enables you to do something when this particular route is encountered, and then when you exit that, it can do something else. So we have a little CSS class which is added and removed in the case of non-landing page stuff. Okay, so that's the FrontController. Now let's move to the Singleton design pattern. We've now exited the stuff that's specific to Meteor, or general to Meteor, I should say, and now we're entering the design patterns which are just specific to Bowfolios. So and this is one which is I think is a really pretty cool design pattern in Bowfolios. I haven't seen this in other Meteor code. Either that's because my code is just cooler, or there's something wrong with what I'm doing. No, there's nothing wrong with what I'm doing. I guarantee you this is cool. Anybody will agree with me once they see. So anyway, what is this? The Singleton design pattern in general is this idea that you want to provide some kind of global variable to the system, and you don't kind of have built-in support for just global variables, or you need some kind of complex global state exposed globally. And so we're going to kind of build something in Bowfolios which acts much like the Singleton design pattern. And just to start off, remember that each MongoDB collection in Bowfolios has a corresponding JavaScript class, and all access to that underlying MongoDB collection is mediated through that JavaScript class. That's so we can do things like consistency checking and make sure that the arguments are valid and so on and so forth. And then also just provide a lot of convenient functions to make it easier to manipulate the collection. So we can do it more easily, and we can do it more reliably if we encapsulate the actual MongoDB collection. So for example, there's a class called Profile Collection, and that manages access to the underlying MongoDB collection, conveniently enough also named Profile Collection. Well, where does the Singleton pattern come in? Singleton pattern comes in that what we're going to do is create exactly one instance of this class, okay, and manipulate that everywhere in the system. And so in the file that defines the Profile Collection class, we're going to export a variable called profiles, and that's an instance of the Profile Collection class. So here we are in the Profile Collection. Because I can't scroll because this is a screenshot, I'll go to another slide, which is the scroll. And at the bottom of this file, you can see that we say export const profiles equals new profile collection. So we stamp out from the prototypical instance a new prototype, new instance of this object, and we assign it to this variable profile, and then we export that. Okay, and then whenever we want to manipulate the profile collection, what we do here is we import that variable called profiles from the profile collection file. Okay, and remember that's bound to an instance of the profile collection class. And then we do stuff. So for example, right here, we invoke the method getPublicationName to find out what the name of the publication associated with the profile collection is, and then we subscribe to it so the directory page can, can have this data available to it. And now that that data is available to it, down here we can again reference this profiles variable and invoke the find method of that collection class, and get back profiles sorted by last name. Okay, on to factory, right? So the factory design pattern creates objects without exposing the underlying logic, so we can do cool things that aren't necessarily available via the standard class constructor method. In Bowfolios, we have an example of the factory design pattern in that we define a method called define in both the profile collection and the interest collection. And here's an example from profile collection. And the notion is that instead of trying to deal with the constructor, it's much more convenient for us to define a special method which will eventually manipulate the underlying state of this class, but does error checking and looks stuff up and asserts various things and so forth. And so we've defined a more complicated kind of constructor for instances of profile that can do additional things. And what's kind of interesting about this is this doesn't return an instance, quote unquote, of the profile collection, because the profile collection is actually a class that encapsulates the entire collection of profiles. So the define method actually returns the doc ID for an individual profile within the collection, which is what kind of makes more sense for this. Okay, so there you have it. We've gone through we've gone through the Bowfolios system. We've looked at a half dozen different design patterns. My hope is now you'll both understand Bowfolios a little better than you did before, and also understand design patterns a little better than you did before.